Hello everyone, I welcome you all. This is Lata Avhad, working as an assistant professor in the Department of Chemistry at KBN9 Arts, Commerce and Science College, Nasik. In today's lecture, we are going to discuss about the alkaloids derived from tyrosine. Now first we will see the biogenesis of unhalonine from tyrosine. So the first structure of tyrosine. From this tyrosine, by using O2 and enzyme, oxidation of this carbon atom takes place and we get L-dopa. So the next step, loss of CO2 takes place and we get this moiety known as dopamine. In next step, by using SAM, methylation takes place over here and we get this moiety. In next step, by using O2 and enzyme, oxidations take place here and we get this moiety. In next step, by using SAM, methylation of this group take place and we get this moiety. In next step, in treatment of pyruvic acid, formation of imine take place and we get in next step, Monich-like reaction take place. Para position in aromatic ring is nucleophilic due to the mesomeric effect. So lone pair of oxygen delocalize over here and this double bond attack on this carbon atom. This bond open on nitrogen and H plus take place and we get in next step, formation of favored aromatic tautomerization. And we get in next step, loss of CO2 take place, that is decarboxylation. In next step, by using SAM, methylation of this group take place and we get this moiety which is known as unhalonine. Next we will see the biogenesis of lophaserine from tyrosine. So the first, in first step, oxidation takes place by using O2 and enzyme and we get L-dopa. In next step, loss of CO2 takes place and we get dopamine. In next step, methylation of this OH group takes place by using SAM and we get this moiety. In next step, this moiety reacts with carbonyl compound. Monich reaction takes place and imine formation also takes place and we get this moiety. In next step, Monich reaction takes place. Lone pair of oxygen delocalize and this bond attack on this carbon atom. These bond open on nitrogen and H plus take place and we get in next step tautomerization take place or rearomatization take place and we get these moiety. In next step decarboxylation take place and we get this moiety. In next step by using some N-methylation take place over here and we get and this moiety is known as lophoserine. Next we will see the biogenesis of salsolinol from tyrosine. So this is structure of tyrosine. So in first step by using O2 and enzyme oxidation take place here and in second step loss of CO2 take place and we get dopamine as a product. In next step dopamine reacts with pyruvic acid and imine formation take place. In next step, the lone pair of oxygen delocalizes. These pi bond attack on this carbon atom and after that protonation take place and we get in next step rearomatization take place and loss of CO2 take place and we get this moiety which is known as salsolinol. Next we will see the biogenesis of papaverine and reticulin from tyrosine. So in first step from tyrosine transamination take place and we get 4-hydroxy phenyl pyruvic acid. In next step loss of CO2 take place and we get 4-hydroxy phenyl acetaldehyde. In next step, one each like reaction take place between aldehyde and amine and we get that is 4-hydroxyphenyl acetaldehyde reacts with dopamine and imine formation take place. In next step, lone pair of oxygen acts as a driving force and these pi bond attack on this carbon atom and here protonation take place on nitrogen atom and we get in next step rearomatization take place and we get non-cochlear. This is known as non-cochlear. In next step, by using SAM, methylation of this group take place and we get this moiety which is known as urine. In next step, by using O2 and enzyme, oxidation takes place Fourier and we get in next step, by using SAM 3 times and methylation take place of this OH group and we get this molecule. In next step, dehydrogenation take place and we get this moiety which is known as papaverine. Instead of O2 and enzyme, if methylation takes place by using SAM of this nitrogen atom, we get N-methylglobulin. This is known as S-N-methylglobulin. In next step, by using O2 and enzyme, oxidation takes place this carbon atom and we get this moiety which is known as S3-hydroxy N-methyl urine. In next step, by using SAM, methylation of this hydroxy group take place and we get this moiety which is known as S-reticulin. In next step, by using NADP plus, imine formation take place Fourier and we get this moiety. In next step, by using NADPH, reduction of planar imine or iminium ion allows changing stereochemistry and we get R-reticulin. This is all about the biogenesis of papaverine and reticulin. Now next we will see the biogenesis of morphine from R-reticulin or tyrosine. As we already see the biogenesis of reticulin to tyrosine. So now we directly see the biogenesis of morphine to R-reticulin. So the first structure of R-reticulin, the structure of R-reticulin also written like that. So this R-reticulin on treatment with O2 and NADPH, 1 electron oxidation of phenol group produce resonance stabilized radical. So we get here is radical and here is radical. In next step, radical coupling take place and we get Solutarity. Is known as solutarity. In next step, the stereospecific reaction of carbonyl with NADPH, and we get this moiety is known as solutarity moiety. In next step, by using acetyl coenzyme, esterification provides here a better leaving group, and we get in next step, this lone pair of oxygen attack on this carbon atom. This bond shifted here, loss of OAC take place, and we get thebine as a product. In next step, oxidation take place, and we get in next step, dimethylation of thebine via hydroxylation, cleavage of methyl as a formaldehyde, and we get neopenone. This is known as neopenone. In next step, plus minus H plus take place, and we get coordinone. This is known as coordinone. In next step, by using NADPH, reduction of this carbonyl group take place, which is stereospecific, and we get this moiety, which is known as codeine. In next step, demethylation of codeine take place, this group, and we get morphine as a product. So this is all about the biogenesis of morphine. Next we will see the biogenesis of berberine from tyrosine. Now we will directly starting from S reticulin, because we already saw the biogenesis of S reticulin from tyrosine. So first, structure of S reticulin. So in first step, oxidation of this tertiary amine take place, vimium ion, by using FAD and O2, and we get in next step, Manish-like reaction take place, and we get this lone pair of oxygen delocalized, this one attack on this one here, this one open on nitrogen, and we get in next step, ketoenol tautomerization take place, and we get scolorine. This is known as S-chlorine. In next step, by using SAM, methylation of this hydroxy group take place and we get tetrahydrocolumbomy. In next step, oxidation and formation of methylene dioxide by using O2 and NADPH and we get S-conadine. This is known as S-canadine, which is also known as S-tetrahydroberberine. In next step, by using O2, formation of iminium salt take place and we get in next step, oxidation via iminium cation leading to the formation of aromatic ring. Berberine as a product. So this is all about the biogenesis of berberine. Next, we will see the biogenesis of S-isothiocyanine from S-orientaline. First structure of S-orientaline. So in first step, oxidation takes place and we get here radical take place. In next step, oxidative coupling take place and we get S-orientaline. In next step, reduction of dienone to dienol. The one-to-oral migration with loss of leaving group favors by formation of aromatic ring and we get orientalinone. In next step, ring expansion take place, loss of leaving group and we get isothiocyanine as a product. This is known as S-isothiocyanine. Now next we will see the biogenesis of residue from L-tyrosine. The first structure of L-tyrosine. So in first step, by using O2 and enzyme, oxidation takes place over here. In next step, loss of CO2 takes place and we get dopamine. In next step, dopamine is reacts with 4-hydroxy dihydrocinnamaldehyde. Which reaction takes place between this amine and this aldehyde group? Formation of iminium salt takes place and we get In next step, one each reaction take place and we get in next step plus minus H plus take place and we get this moiety. In next step, by using SAM, in next step, oxidation takes place here and methylation take place to this hydroxy group and we get orthonylene. In next step, oxidative coupling take place and we get fluoramultine as a product. This is known as fluoramultine. This is also known as homoaparfine skeleton. In next step, by using SAM, methylation takes place over here and we get recycline as a product. So this is all about the biogenesis of recycline and alkaloids derived from tyrosine.